And for our final problem on guided practice 1010, we have one very similar to number 5. This is the number 6 problem. Again, we've got two tangents coming from an external point, and we see that their length is represented by an expression which includes a variable a, and then we're given a length here x. Notice this x is slightly different than the length we had in problem 5. In problem 5, that middle line segment extended from the center of the circle to the external point. Here, this line segment extends beyond the center all the way to the end of the circle. And then we have a 30, and we have another right triangle over here. So let's go ahead and solve for a. So we must have the two tangents being equal in length. So 3a plus 10 must equal 5 times a minus 2 in parentheses. Those two must be equal. So we must solve for a. 3a plus 10, we will distribute, equals 5a minus 10. We can add 10 to both sides, which would give us 3a plus 20 equals 5a. That drops out on the right. And we can now subtract 3a from both sides, which gives us 20 equals 2a. A equals 10. Okay, so the a equals 10. Let's go back to this diagram and figure out what does that mean as far as the lengths of the tangents are concerned. Well, let's draw a diagram of what we're finding out. Okay, if a is 10, then 3 times a is 30 plus 10 is 40, and a minus 2 is 10 minus 2 is 8 times 5 is also 40. So we've got the tangents are each 40 in length, which is, of course, as we thought, they must be equal. We can tell from the top circle that the radius is 30. So we know we've got a radius of 30. And if we draw a radius of 30 to the tangent, to the point of tangency, then we know we've got a right triangle. So if we join the center of the circle to the external point, that gives us a right triangle with two of its legs being 30 and 40. And I don't even need a calculator for this. I know that this leg is 50. How do I know that? Because I know the most basic Pythagorean triple is 3, 4, 5. And what am I doing? 3, 4, 5. And remember that I taught once that every multiple of 3, 4, 5 is also going to be a Pythagorean triple. So if we multiply each of these by 2, we get 6, 8, 10. That's a Pythagorean triple. Multiply 3, 4, 5 by each of them by 3, we get 9, 12, 15. And if we multiply each of these by 10, we get 30, 40, and 50. Okay, so 30 here, 40 here means 50 here. So the distance from the center of the circle to the external point is 50. But we have to figure out what the length would be if we extended it all the way to this opposite side of the circle, because that's what this line is. So that's not that hard to figure out. The radius is 30, so that this extra distance here has got to be a 30. Okay, so we're adding another 30 onto this 50, which means that the x has got to be 80. So the answer for this problem then is that x equals 50 plus 30, or x equals 80. So that is the answer for the last problem on the guided 10.10 guided practice. So this is what it looks like. We've got two tangents that are 40, a radius that's 30, a line segment from C to the external point that's 50, and then we added on a radius to make it 80.